another graph you need to know how to draw is a histogram. And this is for, it should be for continuous data. However, in large samples of discrete data, we can cheat in a way and group them and draw and represent them in a histogram. So the important thing about histograms is, notice here, we got 700 contained here, and then a 300 contained here, and then another 700. The point is, these are different, right? So technically, if you think about it, you've actually, looking at frequency might give you a misleading view. So that's why you have to do frequency density. And another thing to be mindful of here is your rounding. Histograms should have no gaps between the bars, but we got a full 100 not here. And that's because in the question it says to the nearest 100. So what this says, this could actually be 50 to 850. This could be 850 to 1250, 1250 to 2050, 2050 to 3250, and 3250 to 4850. And I'll just, to make it easier, I'll write in our class width, which is just 850 minus 50, then 400. This is 800. This is 1200. And this is 1600. And now what we actually plot on the y-axis is not frequency, it is frequency density. So frequency density equals frequency over class width. And the units of this depends on your data set, but here it would be villages per person. So we'd say villages per person. And so then we'd do our FD calculations, 8 over 800, that'd be 0.01, then we'd do 12 over 400, 0.03, 50 over 800 again, 0.0625, 28 divided by 1200, which is 0.04, and 32 divided by 1600, which is 0.02. So now you need to figure out what scale you're going to use. The highest you need to go up to is this, so 1, 2, 3, 5, 6, 7, okay, so I put your 0.07 at the top, then 0.06, 0.05, 0.04, 0.03, 0.02, 0.01, and 0. And here we're doing population. So we're going from the lowest of 50 to the highest of 4,850. So what we're potentially going to be looking at is a scale that's going to look a bit like 1,000 here, 2,000 here, 3,000, 4,000, 5,000 and 6,000. That's probably the best we can do. And then what we would do is I'll change the colour just to make this easier to see. We'll start drawing our bars. So to go up to 0.01, we're going from 50 to 850. So it's going to be within here. And then to 850. And then for the next one, we want to go 850 to 1250, and we're going up to 0.03. So 1250 is going to be here. And we'll just connect that bar there. Then we're going from 1250 to 2050. And we're going all the way up to 0.60625. Then 2050 to 3250 at 0.04. 1250 is going to be here. And then we'll just draw across. Then the final bar is going to be up to 4,850 at 0.02. Right. Now, important things about this, and you want to also give the label the axes. This is going to be your population. And a few features. The frequency is equal to area of the bar. This is because, well, this is going to be a class width of, this is going to be your class width, and this is your frequency density. So if we multiply class width by frequency density, we get frequency. So that should make sense. Now, we can look at a few things with the histogram. The most important thing probably is modal class, which means the interval with highest frequency density, and that is this one because it has the highest frequency density. And then we can also look at the shape, and we can kind of do this by drawing a bit of a curve over the bars, and we can see that this is positively skewed. There's a few higher values that are skewing the mean to the right. And now we can move on to just a bit of an introduction to the estimates you might have to do. So you may have to do an estimate of the mean. And the way you do that is you just do the frequency multiplied by each midpoint. So the midpoint here is going to be 450 plus 12 times 1050 plus 50 times 1,650 plus 48 times 2,650 plus 32 times 4,050, and you divide that by, well, that actually gives you the total number, which is helpful. Divide that by 150. And so an estimate mean of 2,307. So on average, by using this data, we can estimate that on average about 2,370 people live in one village. And also we can estimate the median. Now this is grouped data, so we just do n over 2. So 150 over 2 equals the 75th number. So have a look at our table. We think, okay, 8 plus 12, that's 20, plus 50 is 70, too low. So our median's going to be in here. Here. And we've already counted 70, so we only need to find the fifth. Is the fifth in here. So what we do is we do 5 over 48, because we're trying to find the fifth number in this class of 48, multiply it by the class width, which is 1200, and we add it to the lower boundary to add it to 2050. And so that gives you 2175. And as we can see, yes, because it's positively skewed, our median is lower than the mean. For both of these estimates, what we do estimate is the data set is evenly distributed in every interval. And that is a big assumption. You could also be asked to do things like, okay, if I estimate the proportion or number of values below a certain value or the reverse, they could say that 30% of the values lie below K. Find K. That sort of stuff. It's all the same thing. You just make that same assumption that all the values are evenly distributed within each interval. In a future video, we will go through lots of these practice questions.